Okay, so now on to the end of this whole factoring stuff. Factoring by grouping. Sometimes you come across stuff that's way too difficult to factor the way we've been doing, right, into just two sets. And so it requires a little more work, a little more thinking. I saved this one for last. Used to teach this one earlier on in this unit, but I saved it for last, so I want to make sure you had a good foundation with the rest of the factoring first. Okay, so factoring by grouping. Here's the idea. It's a process of factoring by looking for greatest common factors. So, as I mentioned in the previous slide, we're going to have stuff like this. Look at this thing. If you look at the back half, right, cover up this first two back half. Oh yeah, it looks like something you could factor. Or you could certainly foil, right, or factor. I'm sorry, the opposite of foil. You'd factor out the 12 first, right, then go back and look at q squared minus 12 and see what you could do. But we have some other stuff on the front here. So what we're going to look at here is first things first, like ones like this, we will take out the greatest common factor. Then we're going to take the second half here. So notice I took out a 4q here. Second half, and we're going to factor that half. And we're going to do that by factoring the greatest common factors out of the front set and the back set. This is, again, after you put them in order smallest to biggest. And I'll do some examples. Don't worry about this. Getting it right away. So once you factor that out, you'll notice you have some similarities that we can kind of throw together. But just to give you an idea, this is what it's going to end up looking like. So to make sure we understand where we're going with all this, we are, again, we're factoring by grouping. So factor out the greatest common factor first, and you're going to want these steps. So you want to put these in your notes. If the polynomial has two terms or three terms, look for a difference of two squares, a perfect square trinomial, or a pair of binomial factors. And I'll explain what that is as we do them, but again, you're going to want these in your notes. If the polynomial has four or more terms, group terms and factor to common binomial factors. As a final check, make sure there are no common factors other than one, obviously. And again, here's an example of what that looks like. So I have this long, lovely term here, right? And you'll notice here, again, it has 1, 2, 3, 4 terms, right? So you can ignore this step 2, 4 terms. Group the terms and factors. So group them in smallest or biggest to smallest, so descending order, right, as far as the powers go. Then we're going to look at common factors. So look at the front set, common factor of 3n squared. Back set, common factor of 2. Pull those out, and magically, when you're done, you end up with this n minus 4 coming out of both. You pull out that n minus 4, regroup the other two pieces, throw them together, boom, you're done, you're factored. Now, sometimes you have to be careful, like this front set could still be factored. In this case, it can't, but sometimes it can be, so. That's what we're looking at. Again, I'm going to do lots of examples of this. This is sort of a preview of what we're going to be doing. So your first example, what is the factored form of 3n cubed minus 12n squared plus 2n minus 8? So again, put them in order. So here, by the way, here's the plan, right? First, group the terms with the highest degrees. If that doesn't work, try another grouping. Your goal is to find common binomial factors. So that's really where we're heading. And by now, you should certainly know what that means, right? Binomial factors, n minus 4, n minus 4. That was actually common in these two. And generally speaking, when you put these in order smallest to biggest, and then, now watch this again. I put them in order smallest to biggest. You did that first, right? Then I took the front two and I factored out the common factor of 3n squared, which left n minus 4 with these front two. If you don't believe me, try it. Take the second pair. Factor out a 2. Oddly enough, that left us with n minus 4 as well. Take that n minus 4, since it's technically just treated as a single factor now, it goes here. The other two get grouped together. They go here. And again, that only works because this n minus 4 and this n minus 4 are the same. Now it's factored. Now, if you're not sure your answer is right, you can FOIL it back out, right? 3n squared times n, 2 times n, 3n squared times negative 4, and n times negative 8. Combine like terms, and you get the same thing back. So I do expect that you check your work. Okay, so what we've got here is a problem just like the one that was in the example. So we start out, and again, please notice, they are in descending order. That is the first thing you want to try. So I'm going to rewrite them because I want you to see what I'm doing here. We're going to have 8t cubed plus 14t squared plus 20t plus 35. If you don't know what I mean by descending order, you need to go back and review some stuff from earlier in this section. So I'm going to take the front half, okay, this half, and I'm going to factor out the greatest common factor. And I notice right away that that is 2t squared. And if you're not sure, spend a few moments looking at it, right? This is even, so I can try 2. 4 doesn't work, so it's going to be 2. And obviously t squared comes out of both. So I'm going to factor out 2t squared. That's going to leave me with 4t in the front and 7 here. Okay? Now I'm going to take the back half. I'm going to factor out the greatest common factor. And you look at it, and 5 goes into both. Not t, just 5. So I'm going to put a plus sign. I'm going to factor out a 5 from both. So a 5 out of here leaves us with 4t. 5 out of here leaves us with 7. Now, oddly enough, when I get done, it's crazy, I know, they both left me with a 4t plus 7. That means I go back and I take the first terms. 2t squared plus 5, and I put them together. Then I take that second set and I put them in their own parentheses. I don't know why I had to. There we go. And I say 4t plus 7. Again, this only works when these two terms, after I factor out the greatest common factor, are identical. That's it. That is the fully factored form of what we just did. Now again, part B says, how is this like what we did before, right? In 8.6. Well, it's extremely similar because I've got this greatest common factor coming to its own set, and then the other stuff that's multiplied by the greatest common factor coming to its own set. And to check it, you just go back and FOIL it. Okay? We're going to do more examples. Don't sweat it. So I've decided we should do one more of these before we move on to the next example. So again, remember our steps. Put them in order from the smallest to biggest when it comes to their powers. So descending order. Or biggest to smallest, I'm sorry. Anyway, after you do that, look at the front half. Factor out the greatest common factor of that front half. Okay? So I'm going to factor out the greatest common factor, 15q cubed plus 40q squared. And that happens to be 5q squared. So I'm going to factor out a 5q squared. Pardon my bad handwriting. That leaves us with 3q plus 8. Now you'll notice right off the bat, hopefully, that means that's the same as this. And let's talk about that here. You might be tempted to just leave that on there and go, oh, I'm done. But no, there's a greatest common factor here. It's 1. At this stage, you do have to factor that out. So plus 1 times 3q plus 8. So now I take these two terms that I pulled out, 5q squared plus 1. They become the front parentheses, 5q squared plus 1. And the back parentheses become this because it's the same set, 3q plus 8. They have to be identical for that to be the case. There we go. That's number 13, by the way. Fully factored. Got to make sure, though. One more step. I almost forgot. Look at this. Make sure now if this were, let's say, q squared minus 1, we could still factor that more. Difference of squares, remember that? That's why we spent so much time on this, so hopefully you recognize those patterns. But anyway, this one can't be, so we're good there. Or this one. You might want to look at it, too. But here's where we're going to kick it up a little bit. I know you're like, yeah. All right. So we take a look at this long thing. Make sure it's in descending order, because sometimes I may not give it to you that way. Today I did, because I'm such a nice guy. It says, do the terms share any numerical or variable factors? Yes. So these guys have a common factor you can pull out of all of them first. Do that first. We'll notice here all of these have a 4q in them. So you pull out that 4q. And I'm going to zoom in just a little bit on that so you can see that a little better. So again, all those had a 4q, so I pulled that out. Now I'm going to zoom in even more so I can talk about it. Alrighty. Once I've done that, leave that 4q on the outside. One of the mistakes I see in my quizzes and tests is kids losing that. Don't lose it. Now this inside, we're going to treat it like we did the last couple of problems we did. Front set, again descending order, front set, q squared comes out, leaving q minus 2. Back set, a 3 comes out, leaving, oh weird, q minus 2. By the way, these are designed to be factored, just so you know that. Okay, so what I do then is take these two, right, the two that got pulled out, the greatest common factor, the q squared and the 3, put them in their own parentheses. The q minus 2 goes into its parentheses. Don't lose the 4q, write the whole thing out. You're done. That's factored. Unless this one or this one could still have any factoring left. So like here, if this were like q squared minus 1 again, or q squared minus 9, or something like that, you'd still be able to factor that some more. Can't do it in this problem, but again, be watching for that, because my quiz and test, I'm telling you right now, there are some like that, where there's more to be done still, and you think, oh, I'm done. No. But this one you do happen to be, because you should recognize these can't be factored anymore there. Okay, so hopefully you tried this one. Again, the first step here is to go back and look at all 3 of those terms, and is there a common factor I can pull out of all 4 of them? First, again, descending order, right? I don't want to forget that. Okay, so, and there is. You find that there's a 3h in all of these. So I'm going to take out a 3h, leaving me on the inside. So again, one term at a time. Leaving me with 2h cubed plus 3h squared plus 4h plus 6. Now, if you get lost in all that, go back and take a look at those factors. Okay, so now we're gonna not lose that 3h, and we're gonna factor the inside ones. Again, make sure descending order. They are, and we're gonna pull out the greatest common factor among the first 2, and that happens to be h squared in this case. So pull out an h squared, leaving me with 2h plus 3. So again, right, pull out an h squared, just the 2h, and the 3 are left. Look at the second set. Greatest common factor here is 2. So plus 2, leaving me with 2h plus 3. I know that's weird, right? Because, oddly enough, 2h plus 3, 2h plus 3. Again, these are all designed to be factored. If they don't work out, look for something, okay? Find what you're looking for there. Okay, so now back to what we've been doing. So don't forget the 3h, just carry it along. This and this, those first 2, those greatest common factors, get put in their own parentheses, h squared plus 2. And then the other one, right, the common one, gets put into its own, 2h plus 3. And that's it, fully factored. Now, if you want to drop this set of brackets, everything outside, you don't need it because it's just multiplication straight across. So really, it could look like this: 3h times h squared plus 2 times 2h plus 3. Now, again, make sure that neither of these have anything left, and they don't. There's nothing else you can do to factor those, especially the one with the h squared. Look at that carefully, but you can't. So there you go, fully factored form of this one. Okay, so story problems, right? I know they seem kind of contrived, and they really are. This one I like because this is, and I know I'm old, right? This is one of my favorite toys as a kid. I'm gonna sound really old, but it's a piece of wood with straps between it. But when you fold it all together, it creates, a rectangular prism. So the volume of this whole thing is this. There's a formula for it. It's called a ladder, by the way, and they're kind of fun because you flip them back and forth, and the things just kind of keep flipping. But alrighty, maybe not for you cool hipster kids. I don't know. So you're gonna factor this thing, and it starts out the same. Look for a greatest common factor. In this case, it was x. We can pull that x out. Once you do that, you got this stuff inside. Now, we know how to factor this stuff inside. You spent a lot of time doing this, folks, right? So really just factor the 6x squared plus 19x plus 15. And real quick, hopefully you figure out that we're going to have a 3, right, and a 2 to make the 6x squared, and then a 5 and a 3 for the 15. That gives us our center term of 19. So again, take out the greatest common factor. Then you can ignore the x for a little bit. Don't lose it though, right? Need it at the bottom. And we get this. Okay? And you factor that the way we've been doing, so that's not new at all, which comes out as 3x plus 5 and 2x plus 3. Okay? And then, now I know all this stuff in the middle here looks like I'm doing something weird, but I'm not. It's the same thing we've been doing. Anyway, when you're done, the possible dimensions are x, 3x plus 5, and 2x plus 3. So when you see a story problem like this, you can really ignore 90% of the words and just go, oh, factor this thing. That's all I'm asking you to do. These are kind of contrived, but again, that's what we're doing. So continuing this, you've got this phrase right here, and you have to factor it. That's really all we're asking. Suppose the prism, blah, blah, blah. It doesn't really matter. What it matters is that you can factor the dang thing. So taking a look at here, recognize that we can certainly take out a 2x. That is the greatest common factor. Inside, that leaves us with 30x squared plus 17x plus 2. Bring that 2x along for the ride. Factor what's left on the inside here. And this is just regular factoring. Notice it's not the 4 terms and all that stuff, right? So let's see, 5 and 6x are going to, 5x and 6 are going to make it my 30x squared. 2 and 1 for the 2. That's how we're going to generate that middle term. And you know what? If you'd like, you know, we can you can FOIL it back out. But this is one of those things we've practiced a lot of. So I hope I don't have to review the idea of, again, I factor. I'm going to get 5x plus 2 and 6x plus 1. And again, if you need to FOIL it back out to check it, that's certainly what you can do. So there you go. So again, look for the greatest common factor first, then just factor the rest of it like we've been doing.